Hello and welcome back to Curiosity Lounge. Before we start, hit that red subscribe button so that you never miss out on any of our videos. The James Webb Space Telescope is the most delayed in the history of telescopes. It is also the most expensive. However, these two attributes have only increased expectations for the observation station as it gets nearer to start delivering the goods. It will uncover many of the universe's secrets, but one of the discoveries stands out because it changes everything: the warp bubble. What is the warp bubble and how will the James Webb Space Telescope help discover it? In this video, we dive into how the James Webb Space Telescope's insane warp bubble discovery will change everything. The JWST is an amazing and novel piece of engineering. It requires lots of ingenuity during the design, fabrication, assembling, and most importantly, launch. The NASA team and their partners had to be extra careful because unlike the Hubble, for instance, they only got one chance to launch the JWST with all its complexities. If anything went wrong, it means the mission failed. It means the loss of tens of billions of dollars in countless working hours and sweat. Everything just had to work because due to its location, there was nothing they could do after sending it off. The JWST now is in orbit 1 million miles away, so far out in space that NASA can't send engineers to fix any issue. The Hubble is much closer, orbiting the Earth at 547 kilometers, and astronauts have paid it a visit to correct some things. But for the JWST, not even refueling is certain at the moment unless NASA comes up with technology for a spacecraft to go all the way and top up the fuel. The JWST will be abandoned after running out of its fuel supply. The orbit the JWST occupies is unstable, and it will require constant course corrections. That is where most of the fuel will go. However, that is not happening soon. As NASA estimates, there is enough fuel to run the JWST for about 20 years. So we have 2 decades of insane cosmic discoveries ahead of us. The JWST is a collaborative effort between NASA and the European Space Agency, ESA, and the Canadian Space Agency, CSA. It is an infrared telescope that can peer further away into space and further into the past than any previous telescope. The engineers chose infrared for several reasons. First off, infrared light can pass through cosmic dust without scattering to the same extent as visible light. The second reason is the phenomenon referred to as redshift, which means that the universe expands light is stretched from visible wavelengths to the infrared spectrum. As such, the telescope can see more distant destinations, and because of the immense size of the universe, redshifting allows us to see into the past 13.5 billion years to be precise. At its location, it will hide in the Earth's shadow to minimize exposure to heat from the trio of the Sun, Earth, and Moon. This protection from heat is critical, so critical that NASA designed a special shield made of 5 layers made from a special material. Each layer was the size of a standard tennis court and had to be folded up or the telescope wouldn't fit on the launch vehicle, but the shields had to be unfurled and precisely positioned to align or they won't work at all. The goal was to prevent interference with the heat-sensitive components on board. The primary mirror of the JWST was the biggest of any space telescope, and it too had to be, you guessed it, folded for the launch. NASA had this in mind when it designed the mirror to be made up of 18 different hexagonal segments and 6.5 meters in diameter altogether. However, while larger than the Hubble, the JWST is actually lighter. It weighed 14,300 pounds on Earth, while the older telescope weighed a whopping 24,500 pounds. At the moment, NASA engineers are working on the 4th stage of the long process to align the James Webb Space Telescope's mirrors, according to a new statement from the agency. The observatory's near-infrared spectrograph near-spec instrument has finished initial checkout and its 3-way mechanisms have successfully been characterized, the statement noted. The instrument will allow Webb to study the fingerprint of light of up to 100 galaxies at a time, giving scientists crucial information about mass, temperature, and chemical composition. At the same time, earlier the team corrected the positions of Webb's primary mirror segments and updated the alignment of the secondary mirror to bring the 18 individual images into focus, then stacked the 18 images to produce one unified image. As things are, we are several months away from the JWST running at full speed, and that is when all the fun begins. Apart from looking back in time to see when the stars were newly formed, the observation station will help in hunting for exoplanets, a very hard process with the currently available instruments. Exoplanets are planets outside our solar system. They are so far away that imaging them is hard. In addition to studying planets outside our solar system, JWST will be able to observe our home planetary system. Its great sensitivity will enable the identification and characterization of comets and other icy bodies in the solar system's outermost regions in such a remote location. These objects are largely unchanged since their formation and may contain clues to the origins of Earth, particularly the source of its water, which may be the result of bombardment by such bodies early in its lifetime. However, few discoveries made by the JWST will come close to the warp bubble because it is going to change everything. Let us start with what a warp bubble is. This is a pretty complicated subject that requires a lot of math knowledge for a detailed understanding, but we will make do with a basic definition. A warp bubble is a bit of space that is contracted in the front and expanded in the back. The contraction and expansion theoretically pushes the bubble and its contents forward at speed surpassing the speed of light, without ever violating the laws of physics, because when you travel using a warp bubble, you are actually not technically traveling faster than light, you are only surfing a bubble of condensed space. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.